Okay, so in addition to solving exponential equations in 4.2, the other types of things you'll come across are word problems. Compound interest uses exponential formulas. That's where your interest starts accruing its own interest. It's not that complicated a formula. It's a future amount equals P, your principal, times 1 plus R over N to the NT. R is your rate in decimal. N is your number of periods per year, and T is number of years. And for continuously compounded interest, when it approaches infinity, it becomes A equals P times E to the RT. E is like pi. It's an irrational number. You'll learn more about this if you end up in Cal 2, where it comes from, using limits. You can even maybe do it before that. But that's a little stretch. Some Cal 1 and Cal 2 skills in that regard. So let's see what happens. Suppose you deposit $1,000 into an account paying 4% interest per year, compounded quarterly. Find the amount of money in the account after 10 years and the amount of interest that accrued. And then suppose it was instead compounded continuously, find the same two things. Okay, so we know that A equals P times 1 plus R over N to the NT. So let's make sure we know what everything is. So this chapter allows you to use a calculator on some things. On the test, you won't have any problems that require a calculator. We'll just have you stop at some point. So it's really just about making sure we know how this works. So our initial amount, P, was 1,000. Our rate is 4%, so that's 0.04. Compounded quarterly, how many quarters are there in a year? 4 quarters. And T is 10 years, because that's what they want to know. And A is our unknown. So A is 1,000 times 1 plus 0.04 over 4 to the 4 times 10. Now 0.04 over 4 is 0.01, so this is really 1,000 times 1.01 to the 40th. And from here, you would have to use a calculator. You can type this into Google on this exact form, and it works just the same, which is what I'm going to do. So let's see. What is 1,000 times 1.01 to the 40th? It is 1488.86. So because it's money, round to 2 decimal places. If you want to know how much is interest, well, if you start with $1,000 and you ended up here, obviously everything but the $1,000 is interest. So $488.86 interest. For the other formula, so suppose it was compounded continuously, this is A equals P times E to the RT. It's still the same P, R, and T. So 1,000 E to the 0.04 times 10 power, because R and T are still the same. So 0.04 times 10 is 0.4. So this is 1,000 times E to the 0.4. And again, from here, you can put it into Google or a calculator. Yes, Google does know what you mean if you just type E, the letter, in there and raise it to the 0.4 power. This is $1,491.82, which means $491.82 interest. So you notice there's not that big a difference between compounding continuously and compounding quarterly. Turns out there's kind of a limit on the amount of money that you can make from this process. And that's the thing that you learn about more in Cal 2. Okay, so what other things can it ask you to solve for in this kind of problem? Find the present value that will grow to $2,000 after 5 years at a rate of 5%. So now we're trying to find the P instead. So we want to know it's going to become $2,000. Compounded annually means N equals 1. R here is 0.05. T is 5. P times 1 plus R over N, so 0.05 over 1 to the 1 times 5 power. So that means 2,000 equals P times, we don't need divided by 1. So this is really 1.05 to the 5th. So to get P by itself, I'm going to have to take 2,000 and divide it by 1.05 to the 5th. Now to do that, again, this would require a calculator. If this were on the test and I asked you to do this kind of problem, you would stop there. You would say P equals this thing. And at this point, you would be putting it into the calculator if you had your choice. It's 2,000 divided by 1.05 to the 5th is 1567.05. So it would take $1,567.05 deposited now at a rate of 5%, compounded annually for 5 years, to become $2,000 in the future. Lastly, find the required annual interest rate to this nearest tenth of a percent to make $1,100 grow into $1,500 compounded quarterly. Okay, this is going to be a little more complicated. So you have 1,500 equals 1,100 times 1 plus our rate is unknown over n compounded quarterly, so n is 4, to the 4 times 3 power. So we have 1,500 equals 1,100 times 1 plus r over 4 to the 12th. To get r by itself is going to be a process. Divide by 1,100. So we get 15/11. When we cancel out the zeros, it's 1 plus r over 4 to the 12th. To get rid of the 12th power, we'll have to take the 12th root. So we'll have the 12th root of 15/11 equals 1 plus r over 4. Subtract the 1. The 12th root of 15/11 equal, or minus 1 equals r over 4. And multiply by 4. So we have 4 times the 12th root of 15/11 minus 4 equals r. And from here, again, you'd have to put it into the calculator. Now, remember that if you're putting something into the calculator, if you're having trouble finding the 12th root, remember that this converts to the 1/12th power if you prefer. So either one of those is fine. So we have 4 times 15/11 to the 1/12th power minus 4. And I see it as 0.1047. Turn it back into a percent, that's 10.47%. But it wanted it in to the 10th, nearest 10th, that's 1 decimal place, so 10.5%, which would be a really good interest rate. You don't get that very often, to be honest. It would have to grow as much as your money in the last problem in less time, so a smaller starting amount. It doesn't happen often. The other type of thing that you could be asked to do is a word problem, exponential growth of deer population. T equals 60,000 times 1 plus 0.07 to the n, where 60,000 is the current population and 0.07 is the growth rate. T is the population after n years have passed. Predict the population in 4 years. It's really just asking you to plug in 4. Now, when you're rounding this, you need to round to the whole number. We could have a philosophical discussion on why there can't be part of a deer, but let's assume you were like, okay, 78,647.76. Yeah, no, there can't be 0.76 of a deer. It's really 78,648. I mean, unless someone once offered me the suggestion that it was mid-birth when the year ticked over to the next year. Another person offered a more disturbing viewpoint that, well, it's about 3/4 of a deer. What happens if the deer was born without one leg? Just round to the nearest whole number. Do everyone a favor and let's not play the hypothetical game. We will finish 4.2 and roll into 4.3 in the next video.